You cannot unscramble an egg. You know this. Everyone knows this. But here is what will haunt you. Nothing in the fundamental laws of physics says you cannot unscramble an egg. Every equation that governs the atom, every mathematical description of how particles interact, every rule that describes the collisions of molecules works perfectly well whether you run the film forward or backward. The equations do not care. They are symmetric in time. If I showed you a recording of two billiard balls colliding and bouncing apart, and then I played that same recording in reverse, the physics would be identical, legal both ways. And yet, eggs scramble, coffee cools, ice melts, people age, empires fall, stars burn out. The universe seems to have a direction. It insists upon traveling, a one-way street through time, and the mystery is this: why? What cosmic conspiracy wrote that arrow into reality when the underlying laws permit travel in either direction? I want to tell you two stories. They seem unrelated at first, but they are the same story told in different languages, and when they converge, something astonishing emerges. The first story begins in Vienna in the 1870s with a physicist named Ludwig Boltzmann. He was a large man with wild hair and a turbulent spirit, and he spent his life wrestling with a question that seemed simple but proved devastating. What is heat? We knew heat flowed from hot objects to cold ones. We knew you could use heat to drive engines and perform work, but what was it really? Boltzmann answered, heat is motion. The temperature of a gas is simply the average energy of its countless jiggling molecules. A hot gas has molecules bouncing violently. A cold gas has sluggish molecules. And what we call the flow of heat is just the statistical tendency of that energy to spread out, to become more evenly distributed, to move from concentrated regions to sparse ones. Boltzmann introduced a quantity he called entropy, a measure of disorder, of how many different microscopic arrangements of particles could produce the same macroscopic state. Think about a deck of cards. There is exactly one arrangement that gives you the cards sorted by suit and rank, but there are billions upon billions of arrangements that look like a shuffled mess. If you throw the cards in the air and let them land randomly, you will get a disordered arrangement, not because the laws of physics prefer disorder, but because there are so many more disordered states than ordered ones. The probability is overwhelming. A scrambled egg has enormously more ways its molecules could be arranged than an intact egg. A room with air evenly distributed has vastly more arrangements than a room with all the air squeezed into one corner. And here was Boltzmann's great insight. Systems naturally evolve toward states with higher entropy simply because there are so many more ways to be disordered than ordered. It is not a law in the usual sense. It is statistics. It is probability overwhelming certainty. The second law of thermodynamics, that entropy always increases in isolated systems, is not like the law of gravity. It is more like the law of large numbers. It is almost certain, but not absolutely certain. In principle, every molecule of air in this room could spontaneously rush to one corner. The laws of physics permit it, but the probability is so small, so vanishingly tiny, that you could wait for the entire age of the universe and never see it happen. Boltzmann was attacked for this idea. Critics pointed out that if the microscopic laws are time-symmetric, then for every trajectory that increases entropy, there should be one that decreases it. Run the film backward and entropy should decrease. Boltzmann's response was subtle and profound. Yes, he said, the laws are symmetric, but the initial conditions are not. The universe began in a state of extraordinarily low entropy. From that improbable starting point, entropy has been increasing ever since. The arrow of time is not written into the equation. It is written into the boundary conditions. It is written into how things started. The second story begins much later, in the 1970s. With a thought experiment I kept turning over in my mind, I called it the delayed choice experiment. Imagine light from a distant quasar, billions of light years away, traveling toward Earth. Along the way, that light passes near a massive galaxy whose gravity bends its path. The light splits, some curving left around the galaxy, some curving right. Then both beams converge and reach us. Now here is the question. Did that photon travel along one path or both? Quantum mechanics says it depends on how we choose to observe it. If we set up our detectors to look for interference, the kind of pattern that emerges when waves overlap, we find interference. The photon behaved like a wave, traveling both paths simultaneously, but if we set up our detectors to determine which path the photon took, the interference vanishes. The photon behaved like a particle, traveling one path or the other. The strange part, we make this choice now. The photon began its journey billions of years ago. It passed by that gravitational lens millions of centuries before humans existed. And yet our choice today, in this moment, determines whether that photon traveled one path or both. How can our present choice affect what happened in the distant past? This troubled me deeply. I designed variations of this experiment, each one more disturbing than the last. I imagined versions where the choice was made randomly at the last possible moment, after the photon had already completed most of its journey. The results were always the same. The photon seems to know what we are going to ask before we ask it, or rather, the question creates the answer. The observation creates the phenomenon. I concluded something that unsettled me then and unsettles me still. The past has no existence except as it is recorded in the present. Let me say that again. The past does not sit out there, fixed and immutable, waiting to be discovered. Until an observation is made, until information is registered, the past remains undetermined. No phenomenon is a phenomenon until it is an observed phenomenon. The universe does not exist out there independent of all acts of observation. Instead, it is in some strange sense a participatory universe. We are not merely spectators. We are participants in the ongoing creation of reality. This is not mysticism. This is what the equations tell us when we take them seriously. Quantum mechanics does not describe a world that exists independently of measurement. It describes relationships between preparations and observations, between questions and answers. The photon has no definite history until we ask about it. And when we ask, we do not discover what was already there. We participate in bringing something into being. I once played a game with my students that I called -20 questions. In the ordinary game, one person thinks of an object and the others ask yes or no questions to discover what it is. The object exists in the mind of the first player before any questions are asked. In my version, the first player does not choose an object at all. They simply answer each question consistently, making sure their answers do not contradict previous answers. The object emerges from the question. It is not discovered, but created through the process of inquiry. The questioners feel certain they are discovering something that was there all along. They are not. They are participating in its creation. I believe this is how the universe works at the deepest level. There is no object waiting to be discovered. There are only questions and answers, bits of information, yes and no. The universe does not have a definite state that exists independently of observation. It has a vast space of possibilities, and observation selects among them. This selection is irreversible. Once a question has been asked and answered, that answer becomes part of the record. It cannot be unasked. It cannot be unanswered. The entropy of the universe increases by 1 bit. Now, let me bring these two threads together. Both stories are about the same thing. The relationship between information and reality, between observation and existence, between the present moment and everything that came before it. Boltzmann showed us that the arrow of time emerges from statistics. The universe moves from order to disorder, not because any law commands it, but because disorder is overwhelmingly more probable. An intact egg can become scrambled through countless molecular rearrangements. But for a scrambled egg to spontaneously reassemble, every molecule would have to move in precisely the reverse direction. And the probability of that happening by chance is so astronomically small that it would take longer than the age of the universe to witness it. The arrow of time is not written into the equations. It is written into the initial conditions. It is written into the fact that the universe began in an extraordinarily low entropy state, a state so improbable that its existence remains one of the deepest mysteries in all of physics. And here is where the two stories become one. If the past has no existence except as it is recorded in the present, if we participate in shaping what we call history through the questions we ask and the observations we make, then perhaps the arrow of time is not merely a statistical tendency. Perhaps it is built into the very act of observation itself. Every time we record information, every time we register a measurement, we contribute to the growing entropy of the universe. Memory itself is thermodynamic. Your brain stores memories by arranging molecules into low entropy configurations, and those configurations can only persist because the universe began in a state even more ordered. To form a memory, your neurons must change their connections. That change requires energy. That energy dissipates as heat. Entropy increases. The very act of remembering the past increases the disorder of the universe. The psychological arrow of time, the fact that we remember the past and not the future, is directly linked to the thermodynamic arrow. We remember the past because recording memories increases entropy, and entropy only increases toward the future because the universe started in an incredibly improbable low entropy state. If you could somehow reverse the thermodynamic arrow, you would also reverse memory. Cause and effect would swap places. The future would become the past. But you would not notice because your memories would point the other way too. Richard Feynman used to say that no one understands quantum mechanics. I would say something similar about time. We use it constantly, we measure it obsessively, we feel its passage in our bones. But when you press on the question of what time actually is, the foundations become slippery. Einstein showed us that time is not absolute, that it flows differently depending on how you move and where you stand in a gravitational field. I showed that the past is not fixed until it is observed. Boltzmann showed that the direction of time is statistical, not fundamental. Put these together and you get a picture of time that is far stranger than the ticking clock on your wall would suggest. Consider this. Every equation in fundamental physics works equally well if you replace the variable t with negative t. Run time backward and Newton's laws still hold. Run time backward and Maxwell's equations still describe electromagnetism. Run time backward and even Einstein's field equations remain valid. Run time backward and the Schrödinger equation of quantum mechanics still governs the evolution of wave functions. The microscopic world does not care which direction time flows. And yet, the macroscopic world we inhabit cares deeply. Eggs scramble, coffee cools, we age, we die. Why? The answer, we now believe, lies not in the laws but in the boundary conditions. The laws of physics permit time to flow in either direction, but the initial state of the universe selected one direction over the other. The Big Bang was not an explosion of hot chaos. It was an explosion of extraordinary order. The matter and energy of the early universe were distributed with remarkable uniformity. That uniformity represents extremely low entropy. The gravitational clumping that would later form galaxies and stars and planets had not yet occurred. Everything was smooth, hot, and dense, but in a very particular way that allowed for all the complexity to come. And from that improbable beginning, entropy has been increasing ever since. The arrow of time points in the direction of increasing entropy because that is the only direction available given where we started. If the universe had begun in a high entropy state, a jumbled mess of thermal equilibrium, there would be no arrow, no change, no evolution, no life, no one to ask questions about time. We exist because the universe began in a state so improbable that physicists still argue about how to explain it. Some have proposed that our universe is part of a larger multiverse, and that low entropy beginnings are rare but inevitable given enough attempts. Others have suggested that the laws of physics themselves select for low entropy initial conditions through mechanisms we do not yet understand. Roger Penrose has argued that the initial singularity had special geometric properties that enforced low entropy. None of these explanations is fully satisfying. The mystery of the initial conditions remains. But notice what all these explanations have in common. They push the question back, but do not eliminate it. Why this multiverse? Why these laws? Why these geometric constraints? At some point, we must accept that the universe simply began the way it began, and from that beginning, the arrow of time follows. This is not a failure of physics. It is a recognition that some questions may not have answers within physics. The initial conditions are given. The rest is consequent. I find it remarkable that Boltzmann, working in the 19th century with no knowledge of the Big Bang, no understanding of quantum mechanics, no awareness of the cosmic microwave background radiation that would later confirm the hot, dense origin of the universe, nevertheless grasped the essential point. The arrow of time requires special initial conditions. Without knowing what those conditions were, he knew they had to exist. The logic was inescapable. If the laws are symmetric and the arrow is real, then something must break the symmetry. That something is history itself. The universe has a past, and that past constrains the present. Experiments have confirmed this picture in striking ways. In 2018, researchers performed a version of my delayed choice experiment using photons from real quasars, light that had been traveling for billions of years before reaching their detectors. The results matched quantum mechanics perfectly. The choice made in the laboratory, after the photon had completed its cosmic journey, determined whether the photon exhibited wave or particle behavior. There was no hidden information traveling with the photon that could explain the results. The past was genuinely undetermined until the present observation was made. Reality is not a movie that has already been filmed and is merely being played back. It is being written in real time, and we hold the pen. Let me tell you what I find most haunting about all of this. In my delayed choice experiments, a measurement made today can shape what we say about events billions of years in the past. The past, it seems, is not independent of the present. It is entangled with it. And entropy, the measure of disorder that gives time its arrow, is itself a measure of information. High entropy states are states where we have lost track of the microscopic details. Low entropy states are states where we retain that information. The arrow of time points in the direction where information becomes harder to recover. Every moment, the universe is forgetting its own initial conditions, spreading out into ever greater disorder, becoming less and less distinguishable from thermal noise. This forgetting is not passive. It is active. It is the price we pay for observation. Every measurement, every registration, every act of bringing a quantum possibility into definite reality increases entropy. The universe becomes more disordered with each fact that is established. Information about the past becomes encoded in the present, but at the cost of losing information about the microscopic details. We trade microscopic knowledge for macroscopic records, and this trade only goes one way. And yet we are here. We are patterns of low entropy persisting against that tide. We are ordered structures that temporarily resist the universal slide toward chaos. We consume low entropy energy from the sun, organize photons of visible light, and we excrete high entropy waste heat into the cold void of space. Our very existence depends on the arrow of time, on the flow from order to disorder, because that flow is what allows work to be done, energy to be extracted, complexity to emerge. Without the arrow of time, there would be no metabolism, no evolution, no thought. We are children of the second law of thermodynamics, born from an improbable beginning that we still do not fully understand. Here's what I believe. The universe is not a machine that we observe from outside. It is a participatory phenomenon that we help create through observation. The past is not a fixed landscape that existed before we arrived. It is a story that we write together with the universe, question by question, measurement by measurement. And the arrow of time, that relentless flow from past to future, from order to disorder, from information to ignorance, is not merely a statistical accident. It is the very process by which reality becomes definite. Every observation, every act of registration, every moment when a quantum possibility collapses into an actual fact adds to the entropy of the universe and moves us one step further along time's arrow. Why does time only move forward? Because the universe began in an improbable state, because entropy counts the ways things can be arranged, because observation requires registration, and registration is irreversible, because the past is theory, and only the present is fact. I have spent my life trying to find the deep, simple principle underlying everything. I believe it has something to do with information. I believe that all things physical are information theoretic in origin, bit from bit. Every particle, every field of force, every bit of space-time geometry derives its existence from the answers to yes or no questions, binary choices, bits of information. The universe comes into being through acts of observer participancy, and time's arrow is the trace left by those acts, the growing record of observations that cannot be undone. When you watch an egg scramble, you are watching entropy increase. When you remember yesterday, you are accessing information stored at the cost of entropy. When you make a choice about the future, you are participating in the ongoing creation of a universe that could not exist without you. The arrow of time is not something that happens to you. It is something you help create. Every observation, every measurement, every thought adds to the record. The past grows, the future remains unwritten, and you stand at the boundary between them, a participant in the greatest mystery of all. I do not know why the universe began in a state of such improbable order. That remains the deepest question, the one that keeps me awake at night even now. But I know that from that beginning, everything follows. The arrow of time, the growth of entropy, the emergence of complexity, the evolution of life, the rise of consciousness, and the strange, beautiful, haunting fact that we can look back at the Big Bang and ask why. We are the universe asking questions about itself. We are matter contemplating matter. We are the cosmos grown complex enough to wonder at its own existence. And through our observations, through our measurements, through our ceaseless inquiry, we participate in the ongoing creation of the very reality we seek to understand. The universe gives birth to consciousness, and consciousness gives meaning to the universe. Neither exists without the other, neither is complete alone. Time moves forward because the past is theory, and the past has no existence except as it is recorded in the present.